Hi guys, Mr. Turble here, and going to try to do a short video on odd and even functions. Okay, so let's jump over here to this slide here, and we see this definition up here that is kind of confusing just a little bit, and so we're going to mostly do some picture stuff. So, but let's talk about this first. We've got even function. So something is an even function if one for which f of negative x is equal to f of x for all x in the domain of the function. So it basically means if you plug a 2 into your equation or you plug a -2 in the equation and it doesn't matter which one you plug in and you get the same answer, that means you've got an even function. So if you plug in an 8 or a -8 and you get the same answer out, that's an even function. Okay, so that's what that's talking about. That one's not too bad, but the definition for the other one's kind of crazy. Odd function, okay, odd function says is one for which f of negative x is equal to negative f of x. So that concept is simply, well, if I plug in -2, that's the same thing as plugging in a +2, working out the whole equation, and then sticking a negative in front of it. And that's a little bit weirder. But let me show you how that looks like on with using graphs, okay, and seeing how this goes. So let's start off with, and don't make fun of my little hearts and squiggly worms here, okay? Doing the best I can. So let's start off with our heart here. Let's see, I'm grabbing my blue one. So here's my heart. I'm gonna put it up here. And you notice the y-axis is going right down the middle, right? Y-axis is going right down the middle. So what's going to happen if I flip that over or reflect it across the y-axis like this? Well, I can, let's see if I can put up wherever it is at. Oh, well, let's see. Oh, I got to have it selected first. That's what's not working. Come down here, hit flip horizontally. Well, you saw it blink, but it really didn't move any, right? And so what we're going to say here is this. If you can take your graph of your function and flip it over the y-axis and you get back what you started exactly, then we're going to call that an even function. Okay? So that means I could probably just grab this little heart and I can put it up here. That'll flip fine. Okay. What if I grab it and pull her down here? Well, that's going to flip fine too. So all those are good. But what happens if I take my heart and move it like over here? If I flip it across the y-axis or reflect it across the y-axis, I'm going to end up with something that looks kind of like this, right? Well, that's not, well, it's basically the same shape, sure, but it's not in the same place, is it? So as long as you keep your graph along the y-axis and you can flip it across that or reflect it across the y-axis and you get back what you started, you can get you an even function, okay? So let's talk about this idea here. So what about a circle? Let's put it over here, okay? So if I put a circle right there, could I flip it left and right? Sure. And as long as I keep it the center on the y-axis, it'll be an even function. Okay, so circles, yeah, those can be, if you put them in the right place, an even function. Well, how about my little triangle here? Let's put my triangle over here. Can I put it in any which way at all on this coordinate plane in which if I reflect it across the y-axis, I'll get back what I started? No, there is no way possible. So my triangle, not an even function, would not go there, okay? What about my rectangle? Well, my rectangle here is, if I reflect that across my y-axis, it will definitely be even. It'll give you back exactly what I had before, right? So it is a even function, okay? So I can move it up, I can move it down, and that's fine. I just can't move it over here because if I flip it over the y-axis, I won't get back what I started. It'll do more like this heart did, right? So that would kind of work. And now I know we're not going to do these kinds of shapes, but it's giving you the concept. How about a star? Star. Hey, there you go. Star works pretty good, doesn't it? We can flip it across. Let me select it and I even show you here. You'll see it kind of blink. Whoop, didn't even hardly see it do anything, but it did. It flipped horizontally. Didn't even see it move, did you? Okay, so star's pretty good deal. Let me move that back over here. Now let's try my little it's supposed to be kind of like a cubic, or a cube root actually. And so what happens if I flip this guy? If I flip this guy, whoops, that doesn't look the same, does it? So this guy is not an even function, and there's nowhere I can put it that if I flip it across the y-axis, I'll get even, that'll be the same thing. Okay, so that's kind of even function. If you flip it across the y-axis, you get back what you started exactly. Okay, so that's how you do it, the picture. Now, but what about this guy? Let's see it. Undo. What about if I rotated this picture 180 degrees? Okay, so let me select it. So what if I rotate it 180 degrees? Well, it's got a little different squiggly, but basically it's the same thing, right? So that makes it an odd function. So if I can turn it 180 degrees, okay, and it's called about the origin, it means the center of it is the origin. So I'll do 180 degrees about the origin. I get back what I started, that's odd function, okay? That makes it an odd function. So now with even functions, I could do and grab this guy right here. Come on. There we go. I could grab this guy and slide it up the y-axis, right? And I could still get an even function. But what happens with this guy? If I rotate it about the origin, right? So what's going to happen here? If I rotate it 180 degrees around the origin, basically what's going to happen here is this point is going to go right about there. You can't hardly see that. Let me do it in green. It's going to go 180 degrees and then basically land down here somewhere, right? And so it would end up looking kind of like that, but down here. Because so it'd be like doing an orbit around the Earth or something like that. So as I turn that 180 degrees around the origin, it would, now, does it look kind of the same? Sure, but it's not in exactly the same place as it was before. So while this blue curve here can be odd, it can only be odd if you put the center of it on the origin, okay? The center of it has to go on the origin for that to work right. So now, let me get rid of those guys. And let's pick this guy up here. Here we are. Now, what other things could I rotate 180 degrees? I wonder if I can do that star. Let me grab that star. Okay. So what happens if I rotate my star 180 degrees? Will it come back to exactly the way it was before? No, no. So is there any way I can put that star anywhere on there if I rotate it 180 degrees on the origin? Mm-mm. So star has shot it even, but not odd at all, right? Can't do odd at all. So star it's a great even possibilities if it's in the right place, but not odd at all. How about the square, the rectangle or a square? Sure, sure. If I rotate a square, a rectangle, 180 degrees, as long as the very center of it, right? As long as the center of it is got the origin right, then I can rotate that and it's good. If it's anywhere else, can't be odd. Okay. Now it's got more possibilities. So the rectangle has possibilities for even and odd, depending on what kind of rotating you do and where you put it. How about circle? Oh, circle. It's a very versatile, isn't it? So if I take my circle and I bring it over here, it's taking its time thinking there. So if I bring it over there, and as long as the center of the circle is on the origin, you can flip it this way. You can turn it 180 degrees. It's going to be just exactly the way it was, wasn't it? So yeah, it's finally caught up to where it's thinking, right? So that I can flip it or rotate it. That's not going to change a thing. So circle, very versatile, can be even or odd. Now, but if I move it up here, still even, right? Flipping it left and right. across that, but you can't rotate it 180 degrees about the origin and get back what you started. So circle has some possibilities for the odds, but it has to be, the center has to be on the origin. Okay. Now, lastly, this triangle. You know, triangle. So it was not a good, it had no chance of ever being even. How about now? Could I rotate it 180 degrees and get back what I started? Well, let's give it a try. See what happens. See. No, no, no. So triangle, no shot at being odd or even, at least not this one. An equilateral might could be even, but you know, hey. So I give you an idea. So if your function can flip across the y-axis, reflect across the y-axis, and get back what you started, that means you have an even function. If you can rotate it around about the origin and get back what you started at 180 degrees, I mean, right, and get back what you started, then you got odd. Sometimes, depending on what the shape is and where it's at, it could be either or both, right? But those are the two things. And so when you have that, yeah, you can do it through the formula kind of deal, but it's much easier just to look at the picture and thinking about this and that. Okay. Hope that's helpful. Take care.